presentation as well. Here it comes. As that's happening, I'll ask Madhusudan Kestur to switch on your video so we can see you, and Raman will fire up the presentation. Madhusudan is director of Ace Micromatic. The company claims to be the largest machine tools manufacturer in India, and all of our, there you are, I see you. All of our presentations today have revolved around the aspect of digitalization, but there are so many different facets to that topic that I'm really happy to have a completely different view of essentially the same topic. Call it IoT, call it Industry 4.0, call it smart manufacturing, but from the perspective of a machine tools manufacturer. So I think we're ready to go. We have your video, you can start, and I think your slides will be, you have to say, share your slides actually yourself to get your presentation going. Maybe we do a microphone check to make sure we can hear your voice.
Thank you, David. I will share my screen now.
There we go. Okay, we see it. Thanks, and feel free to begin. Okay, we see your email. Now we see your desktop. We named our company ARC, so it's always at the top of your list. Easy to find. There we go. Okay.
Thanks, David. Good afternoon, everyone. My name is Madhusudan. I'm speaking from Bangalore. We are a part of Ace Micromatic Group. We are a leading CNC machine tool manufacturing group in India. We manufacture CNC turning centers, VMCs, HMCs, and grinding machines. And we have more than 50,000 machines installed in the field running today. And our customers belong to a wide variety of segments. We have customers working in the automotive segment, aerospace, general engineering, farm equipment, etc. So we work closely with these customers in their digital transformation journey. Working with a variety of these segments also gives us different inputs, and many of our co-speakers have already emphasized that each customer is different. So we keep getting different perspectives and inputs from all of these customers. So my topic is to talk about the Indian context. Why is manufacturing important to India? And subsequently, why is industry for adaptation relevant, and why is it so important for India to make that transformation quickly? Now, in India, we have more than 1 million youngsters coming into employable age every month, which means even to sustain the current rates of average employment rate of 50%, we need to be creating more than 100 million jobs in the next 2 years. That's a big number. That's a significant number. And that is only going to increase going forward. So the contribution of manufacturing to GDP, maybe the best we have seen so far is 15 to 16% in India. And that needs to go up to at least 20 to 25% in the coming years to be able to sustain this kind of job creation. So manufacturing becomes extremely important for India to be able to sustain its society and the economic requirements of the society. According to a World Economic Forum ranking, looking at the manufacturing readiness for the future, India is ranked at around 30, which is a legacy ranking. It categorizes itself as a legacy country. Now, what should India do to enter the top 10 in the coming years? So two things have been identified by the WEF. One is the human capital development, and sustainable resources are the two challenges. So manufacturing has a very key role to play in the GDP growth and socio-economic health of India. Now, why should India look at adopting Industry 4? Global opportunities are coming India's way. India has the opportunity to become a global manufacturing hub for the world, especially with this COVID situation and the anti-China sentiment picking up. India is seeing a lot of investment coming its way, and global opportunities also means global competition. So productivity should be high. We have already seen that our OEMs and tier ones do not accept any bad quality parts. In fact, we do business with Bosch, and the only thing that Bosch tells its vendors is don't send me any bad quality parts. They don't worry about your cycle times or downtimes anymore. They just don't need any bad quality parts because it's going to stop their line. And customers are already experiencing high penalties for non-confirmation. And if you look at the aerospace industry, the traceability requirements are extremely stringent. They are mandated by safety laws and governments. And we already have a 10-year traceability requirement in the aerospace component industry. With the digitalization picking up, internet picking up, there will be demands of mass customization. The batch sizes will go up and the variants will only increase. But the customers expect the same turnaround times. So how do you manage a lot of mass customization, personalization requirements in quick turnaround times? All this will eventually lead to the manufacturing data growing exponentially, which cannot be managed with the current paper-based systems. So we need systems that can handle large data. So for India to even leverage the opportunity that it is being presented with, we need to improve and sustain high levels of productivity with quick turnaround times while still being competitive. So Industry 4 adaptation becomes extremely important for us. So while working with the customers, we try to educate them on the different objectives of the Industry 4 journey. So one could be to look at your own internal efficiencies and utilization, or you can approach it with reducing the cost per component, or it could be just empowering your people at the right time with the right information so that the actions are taken faster and the losses are curtailed. Maintainability of the assets will go up certainly, and you can eventually throw open your systems to MIS and audit without having to spend a lot of time with data generation. So each person can approach it with his own objective. And we also try to project an ROI perspective for our customers. Let us say the average machine hour rate is around 400, whatever it is, rupees or dollars or euros. And let us say the customer is able to obtain an improvement in productivity of 10% and sustain it for 1 year. So we are looking at an increased machine hour rate of 40 units. And eventually, even if you invest a lakh of rupees on monitoring one asset or making it digitally capable, the ROI you're just looking at is around 4 months. Within 4 months, you would have got back your money. So we do this in the context of our CNC machines, which priced at maybe 20 lakhs to 50 lakhs in India per machine. So even for a customer who is having 15 to 20 machines, this becomes very significant because he understands that with a 10% improved productivity, let us say even having 20 machines, the shop owner gets 2 machines free for 1 year because they're able to do it on a sustained basis. So Industry 4 is extremely meaningful and contextual even for a small business owner. Now, what is productivity? So for a high quality component manufacturer in the aerospace industry where the material cost itself is very high, quality becomes extremely important for such a manufacturer, because even if he loses one piece out of 10 pieces, he would have lost all his margins. So quality is productivity for such people. For people who are in the high volume game, their machines should not go down. Their machines cannot go down. So asset utilization becomes very important for him. It's a measure of his productivity. Let us say for our own companies, machine tool manufacturers, we have manufactured 99% of the machine and that last part is missing. It is not available at the right time. So having done the 99% of the machine at a very high efficiency, we are still waiting for that last part without which the machine cannot be shipped out. So for such companies, having right materials at the right time becomes a measure of productivity. So each type of manufacturer, for a chemical industry or a process industry, as Mr. Dharmendra was talking about, adherence to process parameters becomes important. So temperature, pressure, humidity, etc. have to be monitored on a continuous basis. Ultimately, this productivity improvement has to result in profits. So that is when people will start adopting the Industry 4 journey in a more accelerated manner. So we help our customers take a look at where their company is today. And most of our customers are crossing this computerization and connectivity stage where their assets which matter to them are already available in a digital form. The assets are connected. People are able to exchange data. So that is a digitalization phase that most of them have crossed. Then we talk about the Industry 4 phase. So we help the customers try to see what is happening in the shop floors. So that is where you are getting visibility into the operations. Then we help them understand what is happening, why is it happening. So understanding what is happening on the shop floor is the next step, number 4, where transparency into operations is obtained. So the next is being prepared for what will happen in the future. That is the predictive capability. That is where your machine learning algorithms or artificial intelligence will be useful once you have collected a lot of data, which is contextual to your usage. So that is a work in progress. People are still working on those use cases and algorithms of how to really get predictive capability going. And finally, once we have a lot of data, we can think of self-optimizing systems, self-healing systems, or self-moderating systems going forward. So this is the journey that we are seeing. And at each stage, we help them with mapping their requirements into something like a 3-dimensional matrix. So we help them to choose a function, let us say a production function. And in the production function, what would you like to do? You would like to make a enable decentralized decision making. So that is the smart step you would be taking. And how would you do it? With what kind of technology? So we help them to choose the technology. So it's an intersection of the smart, the process, the smart step, and the technology that will give you a direction or an approach how you go about adopting the Industry 4 journey to suit your own requirements. So in our experience, issues are low-hanging in nature, more of transient in nature, a lot to do with the middle management or the communication gap between the top and the bottom. And 15% may be high-tech engineering like speed, feed, etc., or work holding or design changes. And 5% may be connected with labor. So there is a lot of scope for improving the productivity, reducing the losses by just looking at the low-hanging transient type issues. So how do you get insight? So we connect the machines using either some hardware or the later controls yield themselves to be connected over the Ethernet that is readily available in the controllers, CNC controllers such as Fanuc, Siemens, etc. Or if it's a legacy machine, we can deploy some hardware at the machine, tap some signals and get the required data to a central location. So we connect up all these machines into a central server so that real-time insight is the first thing that gets addressed. So when you look at the topology itself, when you get into a shop floor or a factory, there will be variety of data sources. It can be manual data, it can be sensors, PLCs, CNCs, robots, or quality gauges, CMMs, etc. So you your industry 4 partner or your own internal team should have the capability to connect up different variety of sources, data sources, bring it to a central server on premise or in the cloud, and then take it to an analytics engine which does some industry standard computations, which will further interact with your enterprise systems such as ERP or CRM, etc. And then also apply certain business rules and provide alerting either in the form of knowledge systems or quality systems, or immediate action through an SMS or an email kind of an alert. So this is the general approach taken by most of the industry 4 solution providers. The key to this is to have mastery over the ability to connect different types of data sources and bring all the data, normalize it and take it into an analytics engine. So that is the data acquisition portion. Then there is the computation portion, and then there is the business rules engine, which will cater to different types of business rules, alerts, etc. So the team also should be capable of handling different protocols, RS-232, 485, etc. On the later controls, you have direct connectivity through OPC UA or MT Connect. So the later machines, at least in the past 5 years, are already equipped to talk to your servers. The solutions have to be agnostic to the process as well. So it may be turning, milling, grinding, die casting, forging, anything discrete. The solution should be able to cater to that industry. At the same time, you will come across different manufacturers. So there may be tweaks and twists that need to be applied to be able to deal with those different manufacturers as well. So the way we go about executing these projects is we look at the vertical value chain which flows through the company itself. So we start with a specific function, let us say manufacturing, and then extend it to purchasing, logistics, etc. So you are trying to spread the industry 4 journey within the company first. That is called the vertical value chain integration. And once you have achieved some success across the vertical value chain, then you start bringing in your customers, vendors, suppliers, etc. So that is the horizontal integration that you can look at. So the process is first focus on the data acquisition, then analytics, alerting mechanisms, workflows, and then you have a go at the integrated enterprise, first through the vertical integration and then through the horizontal integration. So this is a reference shop floor which we use to convey the solutions that are possible, which are what are the various touch points that the industry 4 solution can offer to a discrete manufacturing industry. So we have looked at standalone machines, we have looked at lines, we have looked at assembly conveyors, backward integration in the form of foundry, a die casting line, etc., maybe a press line. So there are variety of possibilities on the shop floor, and we engage the customer right from the time that the material starts flowing into the factory. We can have traceability applications in place, which can be achieved through the form of a QR code based application or a RFID application, etc. And then the MRP runs or the ERP releases the schedules to the shop floor, where you can have a digital recipe of typically what is achieved through a paper-based workflow in the older days. So we deploy something like a tablet or an HMI at the machine, to which the schedules are sent directly. So the operator typically comes to the machine in the morning, logs in, and then he's presented with a few schedules out of which he chooses one to work with. He's allowed to check the inventory in the SAP or ERP system. Then he can also go to the extent of reserving the inventory and going with the production. So as he starts producing, we monitor cycle time, loading, unloading time, down times, rejections, A lot of significant productivity characteristics of a discrete manufacturing process are monitored. And we provide real-time OE dashboards, which are shown like a display board in the shop floor, just similar to what you see in an airport or a railway station. So a continuous visualization of what is actually happening on the shop floor is available to the operator himself. So which is key to driving his own performance. When he looks at the productivity board, and if he sees that something is not good, he will try to improve it himself. So that is one of the real-time drivers that you can have in the shop floor. The digital gauges that are used today are already capable of sending out data either through an RS-232 port or a Bluetooth connection or a Wi-Fi connection. So we consume the inspection data as well to be able to provide online SPC, statistical process parameters like CPC, PK, XBAR, R charts, etc. are plotted in real time. And we also go to the extent of controlling the process. If there is a tool offset correction that can be provided based on the control limits that we are experiencing at that point in time, that can be affected as well. So we provide automated tool offset corrections to the machine directly without the intervention of the operator. We have also successfully correlated energy consumption and part production to give something called a specific energy consumption for energy guzzling parts like the forging process or a press process. So which is of significant use to the customer. It will go a long way in calculating the cost per component for the customer. With the advent of these modern controllers, like for example in Fanuc something above OITD, and in Siemens with OPC UA enabled controllers, we can delve deep into the diagnostics part where you can understand a lot about speeds, feeds, spindle performance, motor performance, axis performance, etc., which will help the maintenance teams to keep an eye on which machines are coming up for kind of preventive maintenance, and they can prioritize it. The production people also can study if there are some new parts coming up and it has to be proven for the first time. They can look at the spindle performance, spindle loads. And the diagnostics is not only useful for the customer, but is also useful for the machine tool builder himself to be taking these inputs to better his own design going forward. Assembly and conveyor monitoring is also a key useful area where huge conveyor lines, for example, the one we have done in Volvo in Bangalore, it's about an 80-meter line, and visibility is a problem. So for the operator to get attention of somebody who is in a remote office or a remote corner of the factory, we have built systems which will help them to maintain their productivity. So all the way up to outbound traceability, we can think of a lot of applications in the discrete manufacturing space. And all these things come together to finally integrate the data with your ERP systems, with the customer's ERP systems. So this is a sample deployment for OE energy and digital factory applications. So here you see a PLC that is used to connect to the machine to tap the signals. And then you have an energy meter which is also connected to the PLC. There is a 5.7-inch screen through which the operator can interact with the system. For example, to qualify the part or to qualify a downtime reason, he can use that screen, or to mention a rejection, he can do that. And we provide an interface at the machine through which he can access his drawings and process sheets, inspection sheets, etc. So that is what is called as the eShopX solution, which will help him digitize the experience rather than using paper workflows. Coming to OE itself, this is a typical dashboard that a supervisor would use. Each box represents a machine, and the color coding can be controlled by the customer according to the machine or according to his shop standards. What is green, what is yellow, what is red, he can set those colors. And this dashboard is used by a supervisor in a shift, which gives him an idea of what is happening on the shop floor. So this shows KPIs such as production efficiency, which is an indication of the cycle performance, availability efficiency, which talks about its downtimes, the number of parts, etc. So we also enable the customers to consume the data easily using a mobile screen, which gives them visibility into maybe today, yesterday, and the day before yesterday. So 3 days of data is visible through the mobile application, which makes it easy for them to monitor the shops when they are on the move. So that helps the SME industry. So what we call as an and-on board in the shop floor, this is an example of it. So this was deployed in Bosch Nashik, where there is a group of turning machines, a group of machining centers, and a group of grinding machines. And this screen is modeled in the form of the layout. So it is representing the actual machine layout. So this gives a real-time picture of what is happening in the cell. So it enables the supervisor or the operator to take immediate action. This is projected on a 55-inch TV in the shop floor itself. So this is an example of a run chart, what comes out based on the data that comes out of a digital gauge. Easily, a person can look at the trend and then understand what is happening if it is moving towards either the base or at the top. So how is it deviating? What should be done? XBAR charts are available online. And for the diagnostics part, we have something called Machine Connect, which allows you to study your spindle load, speed. It also gives you a visibility into a lot of process parameters, sensor details that have been integrated with the machine. So there is a dashboard which tells you what is happening with each of those sensors. And this is a representation of the spindle load and the RPM. So if there is an underuse or the overuse, abuse of the spindle, this can easily highlight that. So sometimes the customer unintentionally abuses the machine. He loads a low capacity machine with a high requirement part. So in such cases, the spindle gets damaged. So those things can be monitored and alerted to the damage. These are energy profiles. When you are trying to prove a new part, you can study the current consumption or the power consumption. So we have had a lot of successes in India. PK Steels, where the importance was to digitize their workflow, have traceability of the casting from the time it is received in the shop floor till it gets out of the shop as a finished wall. They make huge walls for the oil and gas industry. Trelleborg has been a very good user of our solutions. More than 75 machines we have deployed our solutions in Trelleborg. Ridge Engineering is a good user. Sona BLW, we have implemented a complex workflow where the schedules are released from SAP. It is conveyed to the machines through our server, and the operator will check the inventory, reserve the inventory, and also release the schedule once the production is done. So it's a complex workflow that is achieved by deploying Siemens hardware at the machine and integrating it directly with the SAP. So we have about 70 machines running in Sona BLW. Similarly, we have success stories in different parts of the country as well. In Cooper Satara, we have implemented OE solutions, and they have seen a lot of benefits from the solution just by using it for 3 months. So one customer testimonial that Ridge had shared with us. So they were able to achieve an ROI of more than 200%. So the asset utilization over 3 months from 10 machines has been studied, and they have documented a case study where they have projected that the ROI was more than 200%. So in Cooper Industries, after the solution was implemented and stabilized over a month, the second month, week 1, they have moved from 58% to 60% in the week 2 and 71% in the week 3. So systematically, they have improved their productivity by focusing on the cycle times, loading and unloading times, and eliminating the downtimes, so that their downtimes have gone down from 392 hours in the first week of monitoring to 303 hours in the third week of monitoring. So there is a significant ROI. Like I said, in PK Steels, the objective was to obtain real-time visibility into OE, work in progress, and understand the aging of the product, aging of the casting. So we have deployed Siemens hardware at the machine, and for the HMI, we have used a Dell PC. We have interfaced the two hardware, pieces of hardware, and the data is collected at a central server. So this track and trace report gives visibility into what is happening in the shop floor at that point in time. And then we have an aging report which tells us that from the time the casting entered into the shop till it exited out as a finished wall, how many days were spent. So initially it used to be 20, 19, 18, etc. Now they have come down to around 14 days. So this is what I wanted to share with all of you. Thank you very much for the opportunity, and if you have any questions, I'll be glad to take them. Thank you.
But thanks very much for your perspectives on digitalization from the machine tool industry. I found your presentation also interesting, and like I said before, stark contrast to what we've heard from the process side.